Hi folks, in this video I'd like to show you a program I'm working on. It's going to be both a VST host and an editor for the Yamaha SYXG50 plugin. This plugin is essentially a partial implementation of Yamaha's XG format specification. The XG format was developed in the mid-1990s and it is an extension of the general MIDI specification. It provides a larger selection of voices and various sonic enhancements, effects to enable a higher level of expressiveness. At around the same time, another major musical equipment manufacturer developed a similar extension over the original MIDI standard. I wonder if you can guess who they were. Well, Roland, of course. Their standard is called GS. I'm not sure what GS stands for, maybe General Sound or something. Roland also has a plugin with all the capabilities and features of GS, and it goes by the name of Roland Sound Canvas. The difference between the Roland plugin and the Yamaha plugin is not so much in what they can do, but how much they cost. The Yamaha plugin is freely available. That is thanks to a guy called Veg, and you can find out the story behind this plugin from his website. So in my program, what I'm doing is using that plugin to play all the available sounds and to modify the various parameters the plugin has. As far as I know, currently there isn't a program that can do that. Of course, the plugin can be plugged into any DAW or Herman Scheib's wonderful VST host program, but they don't allow to select sounds and change settings. Not easily anyway. Yamaha did have an excellent application with which you could do absolutely everything imaginable with this plugin or with any of their XG-equipped musical instrument, but that program hasn't been upgraded since Windows 98. It keeps crashing on my Windows 8.1 machine and I cannot get it to work with the plugin. Hence is my initiative to write an application for it. Now I'm going to show you what I've got so far. In this program I'm actually combining the material I presented in two of my earlier video series, one on VST host programming in C++, and the other was about MIDI programming in C#. For this application I created two projects, one for the user interface in C# and the other is the VST host, which is a DLL written in C++. My development environment is Visual Studio 2019 Community Edition. For those of you who are relatively new to program development and want to start off a project like this, I am going to show you how I created these projects and the configuration settings I used. You will also need to be aware of these settings if you wanted to try out my code. I'll put down a link to the source code in the description. So in Visual Studio, create a C++ library, dynamic link library project. Give it a name you like, let's say SYXG50 editor. Keep the solution separate, don't place it in the same directory as the project files. Great! But I'm going to rename the project to SYXG50 plugin so that it doesn't have the same name as the solution and describes better what it is. My installation of Visual Studio enables precompiled headers by default, but I don't want precompiled headers, so I'll delete these lines and remove or delete these two files. But now I have to add in an include for windows.h. I also have to go into Properties, C++, precompiled headers, and select Not using precompiled headers. While we are here, click on Preprocessor and edit the preprocessor directives. Put in this magic phrase _CRT_secure _no _warnings. This is to prevent the compiler complaining about the use of some old-fashioned C functions. Finally, go to Advanced and for the character set it to Not Set. We don't want unnecessary complications with the Unicode characters in unmanaged Win32 code. So far so good. Now to add the user interface project, right-click on the solution and select Add, New Project. Now we are creating a new C# desktop project. I selected WPF application. Call it SYXG50 Editor UI or whatever other name you like. Put it in the same folder where the other project folder is. Done. The user interface will be our startup project, so if it is not already set up like that, select it as the startup project. There is one more important thing to do. The solution platform is any CPU by default. That's not going to work if your machine, like mine, is a 64-bit machine. The Yamaha plugin is a 32-bit program, so we need to change this to x86. You think that it is now all hunky-dory, but no such luck. If you go into Configuration Manager, you see that for the editor UI, the platform is still any CPU. And there aren't any other choices. You actually have to create a new one. For the new platform, select x86. To finish off the configuration, go to Project, Project Dependencies, and make the UI project depend on the DLL project. Also, check that in build order, the DLL is built before the UI. If your development environment is set up like this, then you can start plugging in my source files and get a successful compilation. In the rest of the video, I'll explain how the program works. I encourage you to watch the video to the end rather than immediately sitting down with the source code and trying to make sense of it by reading it. That is less efficient. The source code is not documented. The documentation is this video. And before we start, here is a disclaimer. This is work in progress. There is no exception handling, and there could be bugs, although at present it works for me without problems. Furthermore, this here is only one way of doing things, and probably not the best. Still, I wish someone would have taught me at least half this much when I first set out to write a VST host application. I think I'll begin with showing you the interface between the GUI and the plugin. It will give you an overview of the core functionality. So in DLL main, we have these external methods defined. Load plugin and unload plugin, the names talk for themselves. Then we have get plugin info, which gives us some information about the plugin, like these here. Enable process and disable process are executed when this checkbox is ticked and unticked. When processing is turned on, then we can play sounds using the keyboard, either this on-screen keyboard, or the computer keyboard, or even a piano keyboard connected to the computer, as we will see later. When processing is off, the plugin is not doing any work. Send MIDI short message is an important function. Every MIDI message or command is channeled through this function. These include key presses on the keyboard, or when I select a different sound, or change the volume. And there are two more functions, show plugin editor and hide plugin editor. And they do just that. Hide plugin editor is called when the application is closed and the plugin editor happens to be still open. MIDI device setup occurs in the C# user interface project. Currently, I have two MIDI keyboards plugged into my laptop via USB cables. These are input devices and I can select one of them. Now let's drill down deeper and examine the implementation of these methods. They all talk to an object called host. This is the declaration of the plugin host class. Of particular interest is this load plugin method. Here is its implementation. The plugin is a dynamic link library and it is loaded with the load library method, which is a Win32 API method. For the rest of the details, I want to point you to an earlier video of mine where this exact same procedure is explained. I will put links and pointers in the description under this video so that you can quickly and easily find the relevant information. As we go on, you will realize that much of the code in this application has been lifted out of my two earlier projects about which I have done videos. You can find those videos at my YouTube channel. Get plugin info calls a similarly named function in an object called plugin. This plugin is not the Yamaha plugin, but a wrapper around it. The plugin class interfaces directly with the Steinberg API and has the lower level functions that talk to the actual VST plugin. This class has also been extensively covered in an earlier video of mine in the VSTi host application programming series of tutorials. Now I'll just show you what the getInfo and showEditor functions do. getInfo fetches various bits of information from the plugin using the dispatcher. It collects all that info in this string. As you can see, it is declared static, so it persists between calls. This way, the information is only collected once. On subsequent calls, it is simply returned. In the showEditor function, a MIDI plugin editor object is created with two arguments in the constructor. What is E? E is a pointer to the VST plugin. A effect is a struct in the Steinberg API. The MIDI plugin editor is a classic Win32 Windows class. It has the classic message loop and the WindProc callback function. This is also explained in one of my tutorials. What is slightly different here, I think, is that I made it possible to close the window remotely. In order to do that, the window name and the window class name had to be put into global variables. If we go back to the plugin host, in the hide editor function, first we have to find the window using its name and class name, and then send a WM close message to it. When that message is received, the window is closed. This is just a little programming detail that you might or might not know about. Now with the start process function, things are going to get more interesting. I created this diagram to help explain what is going on. The diagram depicts only some of the objects in the system and some of the functions, but not all. For now, I just want to concentrate on the processing, on how MIDI messages get from the user interface to the plugin where they get processed. If the MIDI events are keyboard key presses, then the plugin will generate sound data, which are sent to the computer's audio interface to produce audible sound. Common control, or CC messages, will result in some change in the plugin's settings. When processing is enabled, processing starts on a new thread. As you can see here, the start process function is invoked on a new thread. And in plugin host, an audio device object and an audio source object is created. The play audio stream function is called on the device object with a reference to the audio source object. In play audio stream, the audio device object is constantly polling for new audio data. It gets the audio data from the load data method. It is in the load data method that MIDI events are converted into audio data by the plugin. By the way, the arrows with solid lines stand for function calls, and the arrows with broken lines for passing of data. These blue squares are steps of execution in the load data method. I briefly talked about the sendMIDI short message function. This is where the MIDI events data is being passed from the UI to the plugin. The link between sendMIDI short message and load data is this MIDI event buffer object. Remember that load data is executing on a different thread, so sendMIDI short message cannot directly pass data to it. SendMIDI short message writes to the buffer and the load data reads from it. This is a bounded buffer, and I explain how it works in another video. I strongly recommend you to watch it. These two broken lines show how the plugin gets MIDI events data and converts them to sound data. One question remains to be answered. It is all very well that we started off the processing, but how do we stop it? It can't go on forever. The show must go on in rock music, but not in MIDI events processing. See, this here is a Boolean variable. When the process is enabled, it is set to true. When processing is disabled, it is set to false. In load data, its value is being checked, and when the isOn variable is found to be false, then load data stops executing. I forgot to say that load data is being called from play audio stream in a loop, so it gets called again and again until this isOn variable becomes false. In the code, execution doesn't go past this line until the buffer becomes closed. IsOpen becomes false. I hope my explanation wasn't too obscure. I didn't show you the code for play audio stream and load data because I do that in other videos you could watch. I put links in the description below. I will develop this program further, and in the future most of the time will be spent on adding new elements to the UI and writing code to change various parameters in the plugin. I also plan to add functionality related to performance, playing and recording, storing performance data, things like that. At present, I can change the volume and pan. These are simple MIDI events, and there are lots more of these. The thing is that if you did one, you've done them all, because they follow the same pattern. You just need to look them up in the XG specification. Sending SYXG messages is slightly more difficult. Well, not really difficult, just more effort. So stay tuned, and if you have questions, I'm happy to answer them in the comments. Bye.